All right. Welcome back to another great video. So it's been some time since our last one. So if you are a returning user, thank you for sticking here. If you are a new one, Matt, welcome to my channel. Here we discuss a lot of tech topics, right, such as system design. We discuss front end, back end, everything around full stack development. It's a bit of data engineering, a bit of DevOps, right? All the interesting topics that you can find. Anyway, the usual way that this works is I have written a Medium article that you can see on the screen. I will link it down in the description. So make sure to visit that if you are somebody who likes to read, right? And if you are someone who likes watching videos, well, you are already here. So let's not waste any much time and get started. All right. So for a person like me, right, who has to give system design interviews, right, a lot of backend interviews that I've given, a lot of full stack interviews that I've given, they tend to have a system design round. So this particular video discusses exactly what steps you need to take for creating a high level design. So people who do not know, system design is made up of two things: low level design and high level design. So low level design usually means your code quality measures, right, like what type of class you need to make and what type of interfaces and how they will communicate with each other and all that good stuff. All right. Whereas high level design talks more about the architecture of the thing, like what components you will use, what technologies you will use, and how you will address several things such as availability, latency, scalability, and other good stuff, right? Which we will dive deep as we go on, right? So the video here, as the title suggests, is basically we are trying to outline what are the steps to creating a high level design for any application. So the aim here is to create a generalized high level design for any type of application. Basically, create a set of principles or rules to reach there, or I would say guiding light for anybody, right? So cool. So in this particular video, we will be specifically looking into availability, right? How to convert your availability requirements into an actual high level design, right? And yeah, let's dive deep into it. Okay. So yeah, to anybody who has given a system design interview or who is about to give a system design interview, make sure that you always have these three things in your hand, right? So requirement gathering is always the first step to making a good application. So the first question you should ask is, what do we have to build in one sentence, right? So what is the description of the application? So for example, you are making something like WhatsApp, right? So you might ask, what do we have to build to your interviewer or to your manager or whoever is giving you the requirement, to your customer, right? They might reply to you, I want a chat application. Okay, cool, right? So what is the next question? The next question is, what are the features of this application? What are the features that you want it to have, right? The functional requirements. So now you get what functional requirements. Functional requirements basically mean what are the features of the system that you are trying to build. And then the third question arises. So for example, for functional requirement, a good example might be like, I want my users to send messages to each other. I want my application to support a concept of groups, right? And yeah, I guess that could be two examples of functional requirement. Now, what are non-functional requirement? Non-functional requirement are what qualities should the application have, right? Now you might ask, what exactly do you mean by qualities, Apurva, right? What you say is very vague. Aren't features qualities of the application? Features are qualities of the application, but we are trying to find out the non-functional requirement, which are not the primary function of the application, but which need to be satisfied, right? Now this might sound a bit, I would say, difficult to digest for anybody, right? So to make it simpler, I have brought them together in these five letters, right? So ALSDS, right? A for availability, L for latency, S for scalability, D for durability, S for security, right? You might create some sentence to remember it, right, according to your requirement, and I'm not going to do that funny job, because and the way I remember this is a very shitty way. The ALS for me is the disease ALS, and DS for me is data structures. So in some way, I remember it like an ALS kid who is trying to learn data structures, which is not a good way to remember it, but it works for me. So whatever floats your boat. Okay, now let's dive a little bit deep into what, not a lot. I'll just give you an overview of what each of these non-functional requirements mean, right? So the way you should understand any concept, right, is what question does it answer, right? So what question does the word availability answer? So availability answers basically how much percent of the time do we expect the application to be up, right? Technical definition for this is uptime. So the percent of time an application is expected to be up or is up or is available is called uptime. Cool, I hope that explains availability to you. Now latency, right? So I think a lot of you might already know what latency is. So latency means basically how quickly are the responses expected, right? Or what amount of delay is okay for your application to have, right? Is tolerable for your application to have, right? So that is called latency. Now scalability, right? So scalability can be described with long and technical sentences and whatever, right? But in very simple words, how many requests per day, per minute, per second can your application handle, or is your application supposed to handle, right? So that is called scalability. Then there's durability, right? So what is durability? So durability, the word itself can mean a lot of things, but when I am mentioning durability, it means what is the lifetime of the data stored in your application. So what all the information that is stored in your databases or caches or any data storage mechanism, what is the lifetime of that data, right? So for example, I send out a message on the chat application that we are building, right? And will I be able to access the same message or the message history after, let's say, 200 years, right? Okay, so that is the question of durability. How much is the lifetime of the data stored? Okay, cool. Then there's security. Last and one of the most important points, right? Security. So what types of attacks are we expecting, and what are the steps we are taking to protect ourselves against them? Cool. So that is your ALSTS, non-functional requirements. All right, cool. So this video particularly focuses on the first letter of that, A, right? So we are trying to convert the availability requirements to your actual high-level design. And if I say it in a sentence, basically, we are trying to understand how the uptime or the percentage of time an application is available affects your high-level design. Cool. I have created a simpler version of a table that tells you what different techniques you should employ based on different percent of uptime, right? And it is a simpler version of a table that is created by another article that is referenced here, which is a very good and deep dive article in the same domain. But I have simplified it because the focus of this video is to get you ready for your system design interviews as fast as you can, or second, get you ready to create a basic, good enough, decent, high level design architecture for your application that you're working on without wasting a lot of time on understanding the logic or understanding the concepts behind it, right? Cool. When you are on a limited amount of time but you still want your x amount of requirements to be satisfied, this guide should give you a good enough guidelines or a set of rules or protocols to get you through it. All right, cool. So just to give you a basic understanding, right? What makes a difference in availability to design flow, right, is the percent of uptime, right? And the percent of uptime is usually calculated, or I would say usually discussed in the rules of 9 or in the multiples of 9, right? So for example, if you see here, the uptime here is 99.9%, right? That is three nines. If you go down, then there's three nines and a five. So this is a bit of an exception. You a lot of articles that you see would also merge these two options together. I've kept it different because it keeps it easier to understand, right? All right. Then if you go down, then there's 99.99%, that is four nines. Then if you go further below, then it is 99.999%, that is five nines. And at last you can see six nines with 99 point, and then there's four nines ahead of it, right? So now you know that, okay, the Apurva did say that, okay, all the factors that we consider, all the measures that we consider for availability uptime is based on number of nines, right? So it is easier to understand, easier to remember. So remember it in the form of how many nines are there, and for how many nines, what action we need to take, right? So of course, a lot of things are mentioned here, and a lot of things mentioned here will make your melt, it will make your brain melt. And what the hell am I saying? Anyway, so to make your journey easier, I am going to give you a brief of each of the technologies that are mentioned here, so that you don't really have to worry and learn all of it, right? All right, cool. So going to the first thing, right? Load balancers. I'm pretty sure a lot of people who are watching this video might already know what a load balancer is. Amazon has made sure that everybody has read about it somewhere or the other, in some way, or I don't know, in some way. Okay, cool. But I will still try to explain it in short, in brief, so that you understand, or people who do not know understand. So a load balancer is basically a network device, right? Now, as the name suggests, this network device is responsible for distribution of load, right? To make sure that the load is balanced across all different services connected to it, right? Okay, so by definition, it is a network device that allows the distribution of network traffic. So network traffic is the load that we are talking about across all different service instances. So service instances, what does this mean? Service instances means your servers, all right? Right. Why do I call them service instances? So a server, or usually a server should run a service, right? Now, multiple servers can run same service, correct? So, but how do we differentiate those servers? We call them service instances, since they are instances of the same service. So that's why A load balancer is a network device that allows distribution of network traffic, i.e. load, across service instances. Okay, so fault tolerance and availability, right? A lot of people find these two words very conflicting or think of it as a synonym, right? Or at least in terms of creating a design, they end up giving the giving similar results or taking similar approaches. And of course, a fault tolerant system is a system that provides higher availability, right? So with my understanding, I would say availability is a larger set of qualities one of which qualities is fault tolerance, right? Okay. In this article, we will only discuss it up till this point. We will have a further special video actually where we try to discuss all these concepts in greater detail. Okay, cool. So load balancer distributes load across services. Now, since it distributes the load across multiple services, right? Only the relevant requests are given to each service server instance or each service, right? Which minimizes the load on each service. That is first thing. Second, if there are multiple server instances running the same service, right? It makes sure that the load is distributed equally, right? Again, minimizing the load on each service, and in turn, decreasing the chances of a DOS attack or a server crash out, right? Due to lot of load, or even the chances of packet drops, right? Since if a server is already running at its full threshold, right, this load balancer might reroute the particular request to some other server instance of it. Cool. So in turn, it increases the availability of the whole application, right? Now, in case of multiple instance services, right? So if one instance goes down, right, the load balancer will direct all the further requests to other working instance. Again, this what it does, it ensures the availability of the service, right? That is another benefit of a load balancer. Now I am talking about a load balancer being in place. Of course, having a load balancer, right? Only a single load balancer might create a problem of single point of failure. So usually it is advised to have at least two or more load balancers, right? To make it even safer, it is advised to have these two or more load balancers in different regions, right? So each region should have at least two load balancers, and you should have multiple regions supporting, right? So multi-region load balancer will further increase your availability. And of course, the best case scenario is having a global load balancer which is available across all different regions, right? So each region has a bunch of load balancers, and since the load balancers are multiple and the regions are multiple, it makes sure that everything is available across regions. Plus, there is no single point of failure, and in turn, the availability is increased. Right? There are some common examples of load balancer. The most famous one is ELB, called Elastic Load Balancer of AWS. But nowadays, there are other ones in the market as well. Almost each cloud company provides their own load balancer. Google provides the Google Cloud Load Balancer. AWS has its bunch of load balancer, and Nginx as well. Right? Cool. Now you know what a load balancer is, and I will not discuss like what steps of load balancers are in what percentage of the nines, right? What percentage of uptime. I think the table does talk about it enough, right? Okay. Now, going to the concept of regular backup. The topic is as simple as it can get, right? So regular backups, as the name suggests, means taking backup of your databases, of the state of each of the systems in regular intervals of time, so that you do not end up losing data when a system failure occurs, right? So regular backups are crucial to minimize data loss in case of system failure, right? It is referred to as storage of the latest state of the system in regular intervals of time. That is the technical definition of it, right? Now, regular backups are okay. When I say regular backups, it usually means that it is a manual step is happening for taking the regular backups, correct? Now, since you are doing it manually, it is ideally better to automate it in some way, right? So when coupled with automation, that means automatically the backups are happening, and you have like set up like a cron job for it, right? That ensures minimal data recovery time is taking place. Also, there is less possibility of human error, right? Backup systems as well, they are making a bunch of money across the market, from startups to big industry players inside it. So like, again, like any other cloud provider, GCP, AWS, Azure, everybody has their own backup systems, and like you can take benefit of. Now, monitoring tools, right? Oh, by the way, one more thing. So nah, I guess, yeah, this is good enough for you. So going to monitoring tools, right? So monitoring tools, the word can also be used synonymously with the word observability tools. Okay, right? Yeah. So as the word suggests, what they do, they observe your system. They observe the health of your system, the performance of your system. They keep track of what systems, what servers are coming up, what servers are going down, if something has gone into a crash loop, if something has gone into failure, if something needs to be replaced, right? So the whole monitoring of the system with generation of analytics and other stuff as well. Plus logging is also part of these observability tools, right? A lot of observability tools are available in the market, right? Such as Datadog, Signos, Prometheus. I believe Grafana, Loki as well are like the open source variants of it, right? And they are used a lot of times. They are also used with stuff like Elasticsearch or Prometheus. Okay, so there are some names in the market, right? So these monitoring tools, I understand that you might have gotten some idea now what a monitoring tool is, right? Now how to take it a step forward, right? So the usually the logic is that these monitoring tools will take a health check of your system, get track the progress of each of the system or state of the system like on equal intervals of time, right? Create a log of it, right? Now for a highly sensitive system which needs higher availability, right? You need to minimize the time between a failure and the detection of failure, right? To do that, you need a real-time monitoring system. So real-time monitoring system is a system that instead of taking I guess monitoring the system at regular intervals of time, what it does is it continuously monitors the system for any progress or failure or any action that event that keeps taking place in your architecture, right? So that is a real-time monitoring system. Now, monitoring systems are very closely attached to the concept of failure detection, right? So failure detection, I guess, is a part of responsibility of monitoring tool, right? So failure detection means that a particular, for example, a server instance has gone down for some reason, right? And you need to replace it with something else. So the detection that a server instance has gone down and sending the notification that okay, this needs to be replaced with something else is automated. By the all this is automated, right? Is called failure detection. And then a step further to it is if you integrate AI algorithms to it, right? So as I told you, the monitoring tools, they keep track of all different events happening in your architecture, in your system, in your application, right? Now based on all these events, all these logs, all the performance metrics that are being captured, right? When you have an AI model in place that processes all this data that has been collected and then predicts before a failure happens that it is going to happen, right? So that is called a predictive analysis that helps us to predict failures before they actually take place on empirical data. By the way, empirical data means data that is uh, data that has been collected from some time, right? From an interval of time is called empirical data. So anyway, that aside, right? So that this concept of using AI algorithms to detect a failure before it actually happens is called early failure detection. So that is, I guess, the final stage of a monitoring tool, the best case scenario, right? Okay. So even in this example, you can see how fault tolerance is connected to increasing your availability, right? Okay, cool. Going down ahead, right? CDN, right? CDN. I guess this is also a fairly popular concept. People who are working in front end in websites, I already know what a CDN is, right? The CDN stands for a content delivery network. So it is a geographically distributed network of servers that caches your website content, right? Like images, fonts, JS files, right? And a CDN, what it does is basically it is similar to what a cache is, right? It minimizes the request made to your actual server, right? In turn minimizing the overall load on your system, correct? And also another benefit is if your origin server fails, right? And CDN has already cached the respective web files, right? So these web files will still be available to your potential clients, to your potential customers, since they will be only fetching the information from CDN, right? And the request would never actually virtually reach your origin server, right? So this overall increases the availability of your application, correct? Now this concept of CDN is can be brought in multiple regions. The similar way we were talking about load balancers, CDN can also be brought in multiple regions, right? And if you bring a concept of CDN across all the regions, similar to load balancer, it is called global CDN, right? So of course, more the number of regions that you support, more will be the availability of your application. And yeah, so the concept of storing frequently requested data at the edge of the network is called edge caching. And so CDNs are basically your edge caching. Another a step further into actually bringing the concept of CDN even in a stronger position is if you use the client machine itself for caching, right? So if you know, for example, a particular set of image is being requested 10 times a day from a user, right? So it is best to keep a copy of that image on the client's machine if it doesn't take too much space, right? So I guess that is an example of edge caching for you, right? So I guess these are like the evolution of how CDN can be used with higher availability requirements, correct? So a bunch of popular CDN services are like Akamai is one, Cloudflare is one, Amazon CloudFront is also a popular one, right? Google Cloud CDN is there. An open source option would also be like using Supabase, right? So Supabase also has a Supabase storage thing that works as a CDN. So there's that, right? Yeah, those are the ones that are on the top of my head. Cool. Okay. Now geographically distributed clusters, right? So we all know Warren Buffett has said that basically diversity will always increase security, right, of your portfolio. Same concept can be used here. And if I say it like a fool, it basically means don't put all your eggs in one basket, right? So as the name suggests, a system is made up of small clusters, right, which work together but are in geographically separated locations. Now, what does this bring into picture on the table? What does it bring on the table? So this protects the system from a single point of failure, right, due to a geographical catastrophe. So, for example, for some reason, a particular region goes down, right? But the other parts of the application are still live, making sure the thing works, right? So it gets rid of the concept of single point of failure. Finally, if you think about it, a lot of things in availability are like push everything across multiple regions and increase diversity of the system and pray that not all of the regions will go down, right? So I guess that is availability, if you ask me. Anyway, uh, going ahead, right? There's a concept of enterprise caching. Enterprise caching is just like a very cool name for caching on steroids, right? So it refers to high speed temporary storage. So caching for critical applications. So that means a high quality cache, right? With which basically is made up of better hardware in a way. Okay. So Redis is a good example of it, right? And they are useful in order to minimize redundant requests and protect the system against DOS attack. But I guess you have already heard that. Okay. Going down below, A/B testing. This is a fairly and widely used concept in the industry, right? So A/B testing refers to basically pushing of UI updates to a sample of of total users. So for example, if you have 10,000 users, right, and you have a new feature that you want to push, correct? You might have heard, uh, you might have heard or experienced actually a lot of UI bugs. If you ask me, a good example is Instagram. Man, Instagram pushes UI updates like every 7 days, and I am honestly disappointed with what they are doing, right? So a lot of them are buggy, a lot of them do not make sense, correct? It affects my interest in the application. I'm pretty sure it will affect the interest of a lot of people as well, right? Uh, nobody likes buggy features or incomplete features in place in an application. It breaks the flow, and there's no guarantee what will work, what will not work, correct? So what you should do, right? So A/B testing means basically division of a set of total users in two samples, right? So sample A and sample B, correct? Now, when you want to push a UI update to it, a new feature to it, you send the feature to the smaller sample of the total users, right? See how they react, what problems they are facing, solve them, make the application or the feature stable, right? And then move to the next sample of it. So basically a rolling release of the feature instead of pushing the release and making it generally available across a larger audience, right? So this way it ensures that some stability is there and availability breaking or an application breaking change does not reach a wider audience, right? So yeah, I guess that does talk about majority of the things across the board that are responsible for availability. So make sure that when you create a design, you have all these things in mind. At least some of them. I know all of keeping all of them in mind is like yeah, you would have to be Mike Ross from Suits, right? So yeah, cool. Hope this provides some clarity and saves you time in your next system design interview or when you are building or designing your next highly available application. In the next part, we will be looking how latency affects the design. And believe me, man, it will be really cool and interesting. So stick around and catch you in the next one. Bye. Oh, by the way, wait. Don't go. Make sure to like, subscribe, and share this video to anybody who might find this interesting. And even if they don't find it interesting, still share. Uh, Bye.